All right, so based off yesterday's videos, it should have reviewed average rate of change and instantaneous rate of change. Average rate of change is just good old slope from 7th grade, right? We use the letter M, where it's y2 minus y1 over x2 minus x1. Or we can just use f of b minus f of a over b minus a. Please remember, f of b, f of a, f of x is just y. B and a are the x increments. So for example, if I said f of x equals negative x squared plus 5x, and I want to find the slope going from 1 to 5, it's just, our change in y over our change in x, where I'll be doing f of 5 minus f of 1 over 5 minus 1. Well, f of 5 just means you're plugging in 5 in for all the x's, so that's going to be negative 5 squared plus 5 times 5 minus, do the same with 1, negative 1 squared plus 5 times 1. Sorry, I got a little scrunched for space there. Over 5 minus 1. Right? Well, 5 squared is 25. It becomes negative 25. Negative 25 plus 25. These two cancel out. So what we have left here is 1 squared becomes negative 1 plus 5 times 1 is 5. Two negatives here then make a positive. Right, so wait, this is, sorry. 1 squared becomes negative 1 plus 5, that's 4, 4, and there's a negative out there, so it becomes negative 4 over 5 minus 1 is 4, so your slope is negative 1. And there we go. So that's good old average rate of change. Very straightforward. The thing is, instantaneous rate of change. Instantaneous rate of change is slope at one point. And yesterday's figure talked about, hey, we've got this graph, and I've got this point, let's call it A, and I want to figure out the slope at A. Well, I need to find, what usually happens, I need to find a different point. I'm going to call it, you can go from wherever, like here. And I'm going to call this A plus H. So it's farther away from A. It's actually a unit of H distance apart there. And there's that line. Now, what happens when A plus H starts moving closer to A? As A plus H starts getting closer and closer to A, what's happening to H? This distance becomes H. This distance becomes H. This distance becomes H. Look at all that. The H's are getting smaller and smaller and smaller. Eventually, once I'm actually there, my H will eventually equal 0. And this is what they were kind of talking about yesterday with that limiting value. So to find the instantaneous rate of change, it is actually, it's still slope, but it's slope at a point, or slope of a tangent line. It's still our y2 minus y1, but in this case, it's f of a plus h minus f of a, all over our x2 minus x1. Well, a plus h minus a just gives us h. But the thing is, we want it where h approaches 0, where that distance between the 2 points gets smaller and smaller and smaller, and I've got now my point there. And now this is the slope of a tangent line or the instantaneous rate of change. So slope of tangent line. So let's do an example. Let's see. Start out simple. Let's say I want to figure out the slope of of the function x squared at x equals 2. So to do this, we have to use our formula. So limit as h approaches 0 of f of a plus h minus f of a all over h. Now, here's the thing. This is all algebra. This is where students get messed up because it's a whole lot of algebra. There's not a lot of calculus here. It's algebra. So when we do this, we have the limit as h approaches 0. F of a plus h. Think of the previous example. How did we do f of 5? We plugged in 5 into x. So that means a plus h is going to go in for that x. So that's going to be a plus h squared minus f of a. That's like f of 1. We plugged in 1 into x. So here this a goes into that x. That becomes a squared all over h. Now when I take this limit, going back to the beginning of this chapter, if I plug in 0 for h, well, that's a plus h is a squared minus a squared is 0 over h is 0. You get a 0 over 0. Again, that's an indeterminate. We've got to do more work. By the way, when you get 0 over 0 right here, that means you're doing this correctly. You're going to have to do more work. You're going to have to do algebra to figure this out. So let's do our algebra. Limit as h approaches 0. Okay, a plus h squared. Here's the deal. That is not a squared plus h squared. A plus h squared is a plus h times a plus h. That means you're doing FOIL or sneaky squares. So this becomes a squared, if I do first, outside is plus ah, inside is plus ah again, plus last is h squared, combine like terms. So a plus h squared becomes a squared plus 2ah, because I've got 2 ah's there. So plus 2ah plus h squared minus, now I'm on the right side, a squared is a squared all over h. Now this is the fun part. This is where I get all geeky with algebra. You can start canceling things out. What can I cancel out? A squared and a squared. What does everything still have in it is an h. So I've got 2, I can take an h out. I went ahead of myself. So I can take an h out. So what I have left is then 2a plus, there's 2 h's here, I only took 1 out, so there's 1 h left, all over h. What happens to h over h? That cancels. Once that h in the bottom denominator cancels, you're done. Because you don't have 0 over 0 anymore. You just have the limit as h approaches 0 of 2a plus h. Plug in 0, you just get 2a. Now, plug in the number that we have. So at x equals 2, that means that a is equal to 2. 2 times 2 is 4. That is your slope at that point. That is the slope of your tangent line. Got it? Okay, let's try another one. Like I said, it's a lot of work, it's a little tedious, but it's all just algebra. This is going to totally enhance your algebra skills. All right, so let's say my function is, let's just do 5x squared plus 2x. And I want to find the slope at one point at x equals 1. That's that instantaneous rate of change. So again, I'm going to take the limit as h approaches 0 of f of a plus h minus f of a all over h. So again, our deal is that we're going to take a plus h and it's going to go in for all the x's here. So that's the limit as h approaches 0 of, I'm going to put in parentheses, 5a plus h squared plus 2 times a plus h. That's my f of a plus h. That's me putting a plus h in for all the x's in the function. Minus. Now f of a is going to go in for all the x's. So that's going to be, and I put that in parentheses, 5a squared plus 2 times a. So this is all of f of a plus h on the left. And this is all of f of a here on the right, all over h. If I plugged in h's as 0, this ends up becoming 5a squared plus 2a minus 5a squared plus 2a. They cancel out. I should be getting 0 over 0. That's the key that I know I did this correctly. So now I have to do my more work. All right. So the limit as h approaches 0 on the left side, a plus h squared. We already did this. That's going to be a squared plus 2ah plus h squared. Plus, distribute the 2. 2a plus 2h minus, on the right side, it's 5a squared plus 2a all over h. Now here I can distribute the 5. Easy enough. That's going to be 5a squared plus 10ah plus h squared. I still have a plus 2a plus a 2h. I'm now going to distribute the minus sign. So minus 5a squared minus 2a all over h. All right, here comes the fun part. What can we cancel out? The 5a squares and the 2a's. And if you look, everything you have left should have an h in it. So now I can take an h out, and I get 10a plus h squared, that means I still have 1h left, plus 2h just becomes 2 all over h. All right, h's cancel out, h over h cancels out, and here I'm just going to take the limit. Limit as h approaches 0, so this h becomes 0, so what's left is just 10a plus 2 at x equals 1. Now I'm bringing that in all the way from the end. So that becomes 10 times 1 plus 2, which is 12. So my slope is 12. So that is pretty much the basis of 2.4 right here. Biggest thing that we want to do now. This is key, and this is something that's now not going to go away. We want to find the equation of the tangent line of f of x equaling, I don't know, let's keep it straightforward. X squared plus 3 at x equals 4. So now we're going to go a little bit more into this. So equation of a tangent line, you need to have this memorized. It is just the equation of a line that we all talked about in chapter 1. Y equals y1 plus m times x minus x1. This is going to happen all year round. You need to know this. This is never going away. Things that we do know. We know our x1. That's the x I'm talking about. That's x minus 4. That's y equals. Y1 is just f of 4 in this case. Just plug in 4. So that's going to be 4 squared plus 3. 4 squared is 16 plus 3 is 19. So that is our y1. Our m just means slope. Slope at a point. That is our instantaneous rate of change. That's what we've just been doing. The limit as h approaches 0 of f of a plus h minus f of a all over h. So all the work really comes in from finding m. M is your slope. M is your instantaneous rate of change. It's slope of a tangent point, slope at one point. All right. So the limit as h approaches 0, f of a plus h. Again, I'm plugging in a plus h into our x here. So on the left, that becomes a plus h squared plus 3. Look at how I put the whole left side in parentheses. Minus f of a. So that goes in there too. And put that whole right side in parentheses. So that becomes, a squared plus 3 all over h. Again, if I plug in h, I get the same thing on the left and the right. They're going to cancel out. I should have that 0 over 0. I'm doing my more work. Limit as h approaches 0. Okay, a plus h squared, we already know, is a squared plus, need more room, is a squared plus 2ah plus h squared. I still have a plus 3 on the left. And now I'm going to distribute the minus sign. So minus a squared minus 3 all over h. Now let's cancel stuff out. Let's do the fun part. A squareds should cancel out. 3 minus 3 should cancel out. Everything I have left should have an h in it, so I can take an h out. So it becomes 2a plus h over h. These h's now cancel. I can now take the limit. 2a plus 0 just becomes 2a. I now plug in the point I'm talking about at x equals 4. That becomes 2 times 4 is 8. That is my slope. That's what goes back over here as plus 8. This is the equation of my tangent line. And there you go.